Hello students, welcome to Go Vidya. So in this session, we will see the questions from TS GENCO 2024, electrical questions and similarly electronics questions from the subject networks or electrical circuits. Okay, so let's see one by one question. So these questions are important and different model of questions they have given, and these questions will help you in your future examinations. Okay, so let's see the first question. The power delivered by the voltage source as a function of A is, okay, so they are asking about the voltage source delivered power. Okay, so here only we need to understand some points. Okay, so when we see the question, we need to get some clear idea what they are asking. So they are asking about power delivered means so the voltage source given power. Okay, so that means the current direction must be in this. Okay, so then only it will be giving. Okay, so power will be given by the source. Okay, so already current in this one is I, we know. Okay, so they have only given here, so directly what we can understand, V into I. Okay, so power whatever we need is V into I. Okay, so this I, so that we will be calculating. Okay, so let's see, here is one node, so I current is coming like this, I1 current is going like this, and AI1. Okay, so AI1 current is coming in this direction. Okay, so we can write down the KCL here at this node. Incoming current I. Okay, so next outgoing current is I1. Okay, so here incoming current is AI1. Okay, so equals to 0. Okay, so we can write down based on the KCL. Okay, so here I1 will be common in these two. Okay, so I minus I1 means here A minus 1 equals to 0. Okay, so minus 1 we need to take common. Okay, so if you take the minus 1 as the common, here it will be 1 minus A. Okay, so equals to 0. Take the I1 to other side, then you will get I equals to I1 into 1 minus A. Okay, so what we need I only. Okay, so directly we need I only, so we need to multiply this V with this I, then you will get the power. Okay, so but you observe one thing. Okay, so in options there is no I1, so I1 we should have some other equivalent. Okay, so that means voltage across these two terminals is directly V. That means voltage here from here to here is, so this is 0, this is V. Okay, so voltage from here to here is V, means I1 equals to this, I1 equals to V by R. Okay, so I1 equals to V by R, then we can write down I equals to V by R into 1 minus A. Okay, so now we need the power. So power delivered by the voltage source equals to V into I. Okay, so small I, so V into I value is V by R into 1 minus A. Okay, so V square divided by R into 1 minus A. This is the answer. Okay, so V square minus R into 1 minus A. Okay, so directly from the dependent current source they have asked the question. Okay, so this is one of the important models only. So similar questions in every exam they will be repeating. Okay, so let's see the next question. A network has n nodes and I independent loops. The number of branches in the network is, okay, by seeing the options only we can understand directly. So this is asking from this equation B equals to, okay, so not B, so we will be writing a number of meshes, M equals to B minus N plus 1. Okay, so based on this, but this they have mentioned as meshes, right? Generally these are meshes, but they have mentioned as independent loops. Independent loops are nothing but meshes only. Okay, instead of writing as M, I will write down as L. Okay, so B is nothing but branches, N is nothing but nodes, 1 is the constant. Okay, so anyhow what they are asking, so the number of branches are, okay, so B equals to L plus N minus 1. Okay, so L plus N minus 1. Okay, so L plus, so otherwise this is L or I. Okay, so this is I they have mentioned. Okay, so let's consider it as a I only. Okay, so anything if they mention as I, otherwise L. Okay, so I plus N minus 1. Okay, so this is the correct answer for this. Okay, so from this equation definitely there will be question. Okay, so in so many examinations, if the examination is simple generally, okay, so this model of questions are coming. So in so many examinations like RRB, SSC, okay, so this kind of examination, definitely this question will be there. Okay, so we need to remember this, M equals to B minus N plus 1, otherwise B equals to M plus N minus 1. Same equation only we can modify like this. Okay, so otherwise N equals to B minus M plus 1. Okay, so according to any one of the equation we can get this answer. Okay, The next question, the H parameters of the following circuit shown in the figure are, okay, H parameters. See, by seeing this network directly, okay, so we can understand, so it's easy to calculate any other parameters like Y parameters or Z parameters. So this is a constant T network, okay, so otherwise, so we can convert this network into some other, but it is not possible to convert, okay. So understand one thing, so to get Z or ABCD, okay, so ABCD parameters for this network, after getting Z, Y also we can find out, okay, so many will confuse immediately whenever they see this network. We will go towards the Z parameters or ABCD parameters or so any other parameters, okay. So but remember what they are asking about H parameter, okay. So forget about what network it is, okay. So whenever they are asking about some parameters, write that parameter equations, okay. So for example, Z parameters, so you know the equations, okay. So V1 V2, okay, so this side, and I1 I2 this side, okay. So it will be repeated, okay. So for example, Y parameters, what you need to write down? Y parameters means, so you have to write down as I1 I2, okay. So in terms of currents, you will be writing the equation. Here it is V1 V2. Y parameters these are, okay. So now ABCD parameters means input side, okay. So input side it will be, that means V1 I1 V2 I2, okay. So like this we have to give, okay. So these are equals to, so we need to remember, okay. So these things, okay, equations we need to remember, so then we can write down, okay. So now what they are asking, H parameters, okay. So before also in 500 series also I have explained this model of question. So this is V1 I1 V2 I2, okay. So I told you to remember in this way, okay, because you have to remember the equations, okay. So that's why V1 equals to I2 equals to, here H11, okay, H12 H21 I1 repeats, okay. So H22 V2, that's it, okay. So if you write the equations, immediately half of the problem will be solved here, okay. So now see the options what they are asking us. So they are asking about all the 4 H parameters. Now for this network, so if you want H12 and H22, what you have to do? You have to make I1 equals to 0. Current equals to 0 means open circuit. I1 equals to 0, open circuit, okay. So if this is open circuit and I will energize with a 1 volt source here, 1 volt, that means directly V2 equals to 1 volt. So current will go inside, 1 volt divided by 1 ohm, then it will be 1 ampere of current is going inside, okay. So what is I2 value? I2 value is 1 ampere, okay. So I2 value is 1 ampere. See, whenever you are doing, okay, so if you are making these two equals to 0 means I1 equals to 0. We have made I1 equals to 0. See, 3 parameters are 3 elements here over already. V1, V2 is over, I2 is over, and I1 is also over. Remaining V1 we have to calculate, okay. So from here to here V1 is nothing but, so like this voltage, okay. I1 current will flow in this one. So that means 1 into 1, it is nothing but V1 equals to 1 volt. All the things we got, voltage and currents, okay. So immediately, so what is the H12? H12 equals to V1 by V2. V1 is 1, V2 is also 1, okay. So then it will be 1, okay. H12 equals to 1, okay. So next one, H22. H22, what is H22? I2 by V2, okay. So what is I2 value? I2 value is 1 and V2 value is 1, okay. So I2 by V2, okay. So this is also 1, okay. H12 and H22, H12 and H22, H12 and H22, H12 and H22. We need to just check, okay, H12 and H22. That's it, okay. So in exam it will take only like half minute, okay. So within half minute we can do all this calculation. Remember, you need to know this equation, okay. So how to remember this equation? So if Z parameter, Y parameter we can remember easily. ABCD parameters, input side it will be, so we have to write down V1 and V2 equals to V1 and I1, okay. For H parameters, remember like this, okay, V1, I1, V2, I2, okay. So if you do like this, you cannot do any mistake, okay. So answer for this question is 1, 1, okay. So remember here, if you try to do this as this equals to 0 first, V2 equals to 0, then you will get H11 and H21, then you can observe, okay. So 0 minus 1, 0 minus 1, again 2 more options we need to do, okay. So luckily we got this, okay. So if any open circuit is possible, try to do the open circuit first, okay. So here current we can make 0, so we are making a open circuit first, okay. So that is the advantage of doing the open circuit first, okay. So then you can get the answer very fast. Understanding, right? So similarly, so many models are there from the 2-port network, and these are important also, okay. So let's see the next question. Which of the following statements are wrong with respect to three-phase systems? Okay, so see, I want to tell you one thing about this question. So whenever statement model of questions, otherwise whenever true or three options are correct, that kind of questions are there, then immediately you need to see, okay, so what they are asking. Okay, so I think so many students have done mistake in this one. So which of the following statements are wrong? Okay, whenever you see, immediately you just put in your scribble pad. Okay, otherwise if it is offline exam, underline that. Okay, so either they are asking a wrong or correct. Okay, so otherwise you will do the definitely mistake. Okay, so blunder you will be doing. Okay, so wrong, they are asking about wrong. Okay, so RYB phase sequence they have mentioned, so you have to read all these four. Okay, so in a balanced delta system, line currents are 30 degrees behind respective phase currents. Okay, leave it. Okay, you cannot understand because in a delta connection, okay, so whether these are line voltages or line currents, right, line currents or phase currents, you need to do all the vector diagram again. Okay, so why this all? Let's go to next one. Okay, in a balanced star system, line currents are 30 degrees behind respective phase currents. Okay, directly. Okay, so by seeing this statement, see, understand, if you see this statement, this is correct, perfectly wrong. Okay, this statement, because in a star connection, okay, so in a star connection, line currents and phase currents both are same only. Okay, so what is this 30 degree behind? So this statement is wrong. Okay, so similarly, okay, so you have understood already what they are asking. They are asking about voltage and currents only. Okay, so nothing more. Okay, so in a balanced star system, line voltages are 30 degrees ahead of respective phase voltages. Okay, let's leave it. Okay, so in a balanced delta system, line voltages are 30 degrees behind. Delta system they are asking. Okay, so in a delta system, so what are the phase voltages and the line voltages? Same only. Okay, so from here to here one phase voltage, from here to here one line voltage, both are same only. Okay, so that means this statement is also wrong. Okay, 2 and 4 are wrong. Okay, so this option is correct. Okay, but if you see, okay, if you don't see this wrong, then what you will do? What you will give? 2 and 4 instead of 2 and 4 you will be giving so 1 and 3. Okay, so similar option is not there, then no problem. Okay, so we have to check whether these are okay, and remember, okay, so whether these two are correct or not, remaining two are correct or not, you need to check generally. Okay, so not now, not in the examination, so you need to check these two. Okay, so in a balanced delta system, line currents are 30 degree behind respective phase currents. Okay, so you write down this now. Okay, so because it will be useful for our future examinations. Okay, so next, in a balanced star system, line voltages are 30 degree ahead of respective phase voltage. Okay, so when you will be understanding this, whether line voltages are ahead or phase voltages are ahead, if you remember 2 wattmeter method, okay, so you might have done like this. Okay, so this is the first voltage. Okay, so this is the second voltage and this is the third voltage. So we will be writing, okay, so first wattmeter reading, so W1 reading. At that time we will be drawing some things. Okay, so this is R phase. Okay, so Y phase, B phase. Okay, so this is RYB. Okay, so RYB in reverse. Okay, so they have only mentioned RYB phase sequence. First R will go, so then Y will go, then B will go. Okay, so according to that I am just giving. Okay, so this is R phase, this is Y phase, this is B phase. Okay, so RY B phase. Okay, so now R and Y are a part of 120 degree, Y and B a part of 120 degree. This is also 120 degree. Okay, so now VRY. Okay, so we'll try to give VRY. Okay, so VRY means VR minus VY. Okay, so VRY means VR minus V. See, these are all not required. Okay, we have already answered the question. Just for understanding, I am explaining this. Okay, so this we can write down as VR minus of minus VY. Okay, so VR plus minus VY you can write down. So that means VR is there, minus VY you should have. Okay, so VY is here, so minus VY. Okay, so where is minus VY? So opposite to this is minus VY. Okay, so this is minus VY. We have to add these two. Okay, so we need to add these two vectors. Okay, so we will extend this from here and we will extend this from here. So here you will be getting VRY. Okay, so this is VRY vector. Okay, so exactly 30 degree. Y means if you give minus of this, this is 60 and this is 60. and these two are same magnitude, then it will be exactly bisecting that angle. Okay, so that is from here to here it is 30 degree. Now this is VRY, this is VR. Okay, so tell me what is there in a balanced star system. Line voltage are 30 degrees ahead. Okay, so 30 degrees ahead, this is line voltage, this is phase voltage. That's enough. Okay, so we can prove this. Okay, similarly in a balanced delta system also, line currents are 30 degrees behind respective phase currents. Okay, so this is the question. So no need to do the three-phase system. Okay, so no need to understand entire three-phase system. If you have done the 2 wattmeter method, then you can directly answer this. Otherwise, you should know whether voltages are common in a star and star, or voltage currents are common in the star. Okay, so like that we can able to solve this question directly. Okay, the next question. For the circuit shown in the figure, the potential difference between points X and Y is, okay, so they are asking about potential difference. Okay, so if anybody wants to raise the so this is some of the wrong formation of questions. Okay, so you see one thing what they have asked, they have copied from something. Okay, all resistance values are in ohms, so that's okay, no problem. What they are asking, for the circuit shown in the figure, the potential difference between points X and Y is, they are asking about voltage directly. Okay, so voltage, we need the value only. In options they should give directly the value. Okay, so nothing else they should give. So just they have copied from somewhere. Okay, so and they have just modified the options here. Okay, see what they have given. So from X to Y we need to check the voltage. Okay, so from X to the Y, okay, we need to go in this direction. Okay, so not only in this, either in different direction also we can go, there is no problem. Okay, so but you see one thing. Okay, so in this loop there is one source is there, so definitely 2 volt will give some current like this. Okay, it cannot go in this way. Why? Means there is no other path to come back. Okay, so whenever how current will flow, whenever there is closed path, then only current will flow. Otherwise, see, if this current can go like this, it cannot come back in a same direction. Okay, it should come in a different direction. Okay, so that's why so this 2 volt will supply the current in this direction. That means in this series, these two are connected in series, so that's why 5 ohms is there. Okay, so then current is nothing but 2 by 5 amperes. Okay, so in this direction. Okay, so then 2 by 5 amperes will be going like this. Wherever current enters, that is plus, wherever current leaves, that is minus. And similarly here 4 volt will supply some current in this direction like this. Okay, so total 8 is there. So that means what is the current going in this way? So 4 divided by 3 plus 5 is 8 amperes. Okay, so this is the current. Okay, so now here it is plus, here it is minus. Okay, from X to Y we need to write down. Okay, so that means Vx minus Vy is equals to, okay, so Vx to Y means Vx minus Vy. Okay, we can write down. Otherwise Vxy we can write down. Okay, so Vx to Y is nothing but minus 3 into, okay, so minus 3 into 2 by 5. Okay, so here first minus is coming, next plus. Okay, so minus 4, next plus is there. Okay, so plus 3 into 4 by 8. Okay, so 4 by 8 means 1 by 2. Okay, so this is the voltage. Okay, so total voltage is this one. Okay, so now we can give it as minus 6 by 5. Okay, minus 4 plus 3 by 2. Okay, so plus 3 by 2. Okay, so we can take the common. Okay, 10 is the LCM. So then minus 6 into 2, minus 12, so minus 40, so plus, so 5 3s, okay, so 5 3s is 15, okay. So then you can get minus 40 plus 15 minus 12 is nothing but plus 3, okay, so plus 3 minus 40 is 37, okay, so minus 37 divided by 10 is nothing but minus 3.7, okay. So that means X to Y voltage is minus 3.7 means Y voltage is higher. Okay, so from one point to another point voltage is negative means another point is at higher potential. Okay, so that means here which is higher potential? X is lower potential, Y is higher potential. Okay, so we can understand that. So that means, they have already marked the question. Okay, that's why I'm going to this option. X is lower potential of 3.7 volt with respect to point Y. Okay, so this is correct. Okay, so X is lower potential, value is different. Okay, so X is higher potential, so value is different. Okay, so X is higher potential, this is wrong. Okay, so that's why option 2 is the correct one for this. Okay, so this is also one of the simple questions and basic questions they have asked. Okay, and the next question, find the current ID following through the diode and voltage VAB in the circuit shown in figure. Assume diode is ideal. Okay, so assume diode is ideal. Okay, so diode is ideal only. By seeing this question directly, some people will confuse. Okay, so there is some diode. Okay, so what we have to give, so we need to understand that. Okay, so first of all, whether this diode is conducting or not, we need to understand that. Okay, so we need to understand that diode is conducting or not. Okay, so current, if diode is not conducting, current equals to 0. Directly first option will be correct. Okay, so if diode is not conducting, okay, so that means we need to check voltage here and voltage here. That's it, voltage here and voltage here. So what you will do, voltage source in series with resistance. See, we need to know these elements we can change to anything. Okay, there is no problem. If at all they are asking about current here or current here or current here or current here, we cannot change the network. Okay, so now we need the current here. Okay, so that's it. So no need to so just directly follow. Okay, we can eliminate all these things by following certain rules. Okay, so now 10 volt in series with 4 ohms, we can modify the network as 10 by 4. Okay, so 10 by 4 is nothing but, so 10 by 4 is nothing but 5 by 2. Okay, so 5 by 2 amperes current source in parallel with 4 ohms will come here and another 4 ohms. Okay, voltage source in series with resistance can be transformed as current source in parallel with same resistance. Okay, now 4 ohms will be coming here with the current source and 4 are connected in parallel, so then we can give it as 4 and 4 connected in parallel. So 4 and 4 connected in parallel means you will be getting 2 ohms and here it is diode. Okay, so here also current source in parallel with the resistance is there, we can transform as voltage source which is value 2 into 1. Okay, so 2 volt in series with 1 ohm you can give. Okay, so 2 volt in series with 1 ohm. Okay, so directly we can give, this is 2 volt. Okay, so now no need this side diode, one side voltage we know this is 2 volt, this is 1 ohm. Okay, so 1 ohm. Now this also we can change. Okay, so current source in parallel with resistance means 5 by 2 into 2 is nothing but 5 in series with 2 ohms you can write down. Okay, so this is 2 ohms in series, 2 ohms in series, and here you will be getting 5 volt. Okay, so now that's it. Okay, so to flow the current from one side to another side, there should be higher potential this side, lower potential this side. 2 volt is this side and 5 volt is this side. So then directly we can find out whether this current will flow through this diode or not, whether diode conducts or not. Okay, so total 5 minus 2. Okay, so total how much? 5 minus 2 means 3 volt. So will be there across this diode, divided by current means 2 plus resistance is 2 plus 1, so which is nothing but 3. Okay, so that is nothing but 1 ampere. Okay, so 1 ampere will be the current flow. Okay, so now what they are asking? They are asking about voltage from A to B. Okay, so voltage from A to B. So this is A and this is B. Okay, so you can observe 1 ampere current is flowing like this from this to this. Okay, so from this point to this point we need to check. So that means 5. Okay, so otherwise A to B. Okay, so from this to this we need to check. Okay, so current enters, this is plus, this is minus, 1 ampere is flowing in this direction. That means minus 2 plus 5. Okay, so minus 2 plus 5. Okay, so that is nothing but VAB. Okay, so A to B. Okay, so A to B means VAB. Okay, so that is nothing but 3 volt. Okay, so directly by seeing only we can do, no need to do all these calculations. Okay, so in exam you should have done this within half minute. Okay, so 1 ampere and 3 volt. Okay, so find the equivalent inductance of the network shown in the below figure. Okay, so equivalent inductance they are asking. Okay, so generally we will be learning about whenever two inductors connected in parallel. Okay, so whenever two inductors connected in parallel, whether they are aiding or opposing, mutual inductance will be there. This we might have learned, okay. So but three inductances are there here, okay. So how you have to do this? See, if you can find out equivalent inductance between these two, okay, so that's what they are asking, right? Find equivalent inductance of the network shown in the below figure, okay. See, that means some voltage will be there between these two. If you apply some voltage, so that means it may be AC voltage or DC voltage, okay. So just for fraction of seconds, then definitely some current will be flowing inside, okay. So then what is the relation between this voltage and current in terms of inductor? So then V equals to L into di by dt, okay. So di by dt, like this we can write down, okay. So that means voltage equals to L into di by dt. That means directly whether whatever inductance is there, this is equivalent inductance, okay. So we need to get this inductance, okay. So now we can understand something. If some current is going inside, so some of the current will go here, some of the current will go here, some of the current will go here, because all three are connected in parallel, okay. So how to do this question? So we'll try to find out. So this is the, I will consider voltage here is V, okay. So that means here also V only, from here to here voltage is V, means this node voltage is V and this node voltage is 0 volts, okay. So this is a general method of calculating the equivalent inductance, or we are writing just KVL equation, KCL equation, okay. So first I will write down this current and this current and this current, that's it, okay. So how you will represent? So algebraic sum of the currents at a node or junction is equals to 0, okay. So we can write down that, okay. So similarly, so first one, okay, so what is the current from here to here? So first current is I1 equals to V divided by, okay, so V divided by, okay. So we can write down using this also, okay. So we can write down using this also. So that means directly I will try to write down di by dt, okay. So that means di1 by dt, okay. So I will write down this. That means V di1 by dt equals to V by L equivalent, okay. So L equivalent, okay. So in terms of first one, okay, so first current di1 by dt equals to V divided by, so what is the inductance in this one? Inductance we need to check, okay. So self inductance is 25, okay, self inductance is 25, but mutual inductance from here to here is 10 Henry, okay. So this is 10 Henry, aiding or opposing, this is 10 Henry is aiding, because here current entering, here also current entering the dot, okay. So that means plus 10, okay. So then from here to here, this is aiding or opposing, 10 Henry is there, mutual inductance, aiding or opposing, here current is leaving at dot, here current is entering at dot, okay. So that means minus 10, okay, so minus 10. So that means V by 25, okay. So this is the first one, okay. So similarly we can write down di2 by dt, okay. So di2 by dt. So this current we need to write down, okay. So in this branch we need to write down. So voltage is same, okay. So V divided by 30. This is opposing, okay. So here current entering, here current leaving, right, okay. So 30 minus 15, and from here to here 10 is there, okay. So 30 minus 15 plus 10 is there, okay. So that means it will be again V by 25, okay. So similarly third one also will try to write down, okay. So di3 by dt, okay. So that means V divided by 35, okay. So this is self inductance, in this branch inductance is 35, okay. So 35, and this is opposing, okay. So this is current is leaving, current is entering, okay. So that means opposition here, so minus 10, from here to here again opposition, okay. So that means minus 15, okay. So what you will be getting? 35 minus 25, okay. So V by 10, okay. So all three di by dt's we are getting, okay. So anyhow in general, okay, so this is the total current I equals to I1 plus I2 plus I3. Similarly di by dt equals to di1 by dt plus di2 by dt plus di3 by dt, okay. So no need to write all these things, okay. So directly we can get, okay. So if you add all these three, that's enough, okay. So then we can write down di by dt is equals to, we need to add all these three, okay. So because these values we have V by 25 plus V by 25 plus V by 10. Okay, so we can take the LCM. Okay, so LCM what you will be getting, so directly 250. Okay, so I will just multiply with multiply with the 10 into 25. Okay, for easy calculation, 250 you will be getting 10 into, okay, so let's put this one as so V common. Okay, so V common, so here you will be getting a 10 plus here also 10 plus here 25. Okay, so 25, so total it will be, so V into, so 25 plus 10, 35, 35 plus 10. Okay, so 45 divided by 250. Okay, so we can simplify this, so this is di by dt. Okay, so 45 by 250 means, okay, so we can divide with okay, let's see the options, we can divide with 9. Okay, so 9, okay, so 9 5s we can do, otherwise with the 5 you can divide. Okay, so this is the 5 9s 45, so 5 5s 25 and 0. Okay, so 9 by 50 into V we got. Okay, so here di by dt equals to V into 9 by 50. Okay, so directly, so you have to choose 9 by 50, then it's wrong answer. Okay, so we need to get it in the actual form. Okay, so how it is, V equals to, in inductor V equals to L into di by dt. Okay, so L into di by dt. Okay, so V equals to 50 by 9 into di by dt. Okay, so V equals to 50 by 9 into di by dt. Okay, so this is the answer. So the L value is nothing but 50 by 9. Okay, so this so many students, almost 99% of the students will not be answering this question, because so there are so many inductances and mutual inductances also there. Okay, so we have to, this is the only model, only way you can solve this question. Okay, so there is no other way. So in classes also I have not explained this model of question with the 3, I have not explained, but so while writing the equation, okay, so how to write the equations I have explained. Okay, so whenever mutual inductances are there, how to write the KVL equations. Okay, so that I have explained. This is the new model of question. Okay, so even in exam only directly I have solved this now. So you can understand this model of questions also one of the new models. Okay. The next question, in a series RLC circuit with R equals to 230 volt, the voltage and the frequency of the main supply are 230 volt and 50 hertz respectively. On taking out capacitance from the circuit, the current lags the voltage by 30 degree. On taking out the inductance from the circuit, the current leads the voltage by 30 degree. The power dissipated in the RLC series circuit is, okay, so they are asking about RLC series circuit. Okay, so this is R, L, C. Okay, so R, L and C, they are giving like this. Okay, so the source voltage is 230 volt and frequency is 50 hertz. Okay, so R value is 230 ohms and L value and C value they have not mentioned, but they have mentioned one condition. Okay, if capacitance we will be removing. Okay, so on taking out capacitance from circuit, current lags the voltage by 30 degree. Okay, so current lags the voltage by 30 degree. Okay, so what it means, so the power factor angle phi equals to tan inverse of, okay, so whenever capacitance is not present at that time, XL divided by R. Okay, so XL divided by R. Okay, so and similarly whenever inductance is removed, okay, so then it is tan inverse of XC divided by R. Same value we are getting. Okay, so this is 30, so this is also 30, this is leading and one is lagging, another one is leading. That means R value is same or tan function is same, everything is same. What it means, XL equals to XC. This is technical way of proving. Okay, otherwise no need, when you are in an exam no need to prove this XL equals to XC directly. So whenever this is the voltage, this is the current, whenever inductor we are taking out, current will come 30 degree lead. Whenever whenever capacitor is taken out, then current lags the voltage by 30 degree. That means what it is, directly it is a resonance condition. Okay, so XL equals to XC, no need to prove, this is technical way of proving. Okay, XL XC, so both are 30 degree only, XL XC both are same only here. Okay, so no need to prove this. Okay, so directly whenever, okay, both are 30 degrees, if you taken out inductance, it is leading. If you taken out capacitance, current is lagging. Okay, so then immediately we can do, for example, different angles they have given, this is 30, this is 45, you can do like this. XL value you can get and XC value you can get. Relation between these two also we can get, and from then you can proceed. Okay, so now directly here resonance condition. In under resonance condition, what is the power dissipated? Okay, so power dissipation is only in the resistor. Okay, so V square divided by R. Already whatever they have mentioned, it will be RMS value. Okay, so RMS value only they will be giving. So directly 230 whole square divided by R value is also 230 volt. Okay, that means 230 watts. Okay, so 230 watts will be the answer for this. Okay, so like this we can do this question. Okay, so one of the models, so previously they used to give in the engineering services examination in the mains. Okay, so in the mains descriptive they used to give with the different angles. Then after onwards we need to find out one by one. Okay, so this model of question is new for the GENCO-TRANSCO examinations. Okay, the next question, in a 3-phase 400 volt 4-wire system, one incandescent lamp is rating 230 volt 100 watt is connected between R phase and neutral, and another incandescent lamp of rating 230 volt 200 watt is connected between Y phase and neutral. If the neutral wire breaks, then okay, so what they have given, if the neutral wire breaks, what will happen? That's what they are asking. Okay, so what is the use of this neutral? See, so for example, so this is R phase and this is the neutral. They have mentioned already. So 4-wire system. Okay, so this is the neutral and it is going to the ground. Okay, so it is going to the ground, and this is the another side. Okay, so another side, this is R phase, this is Y phase. B phase they have not mentioned anything. Okay, so there may be current flow and they have already mentioned. Okay, so 3-phase 400 volt 4-wire system. Okay, so it is also connected to the system, but there is no load connected here. Okay, so now what is happening? So whenever loads are different, how we can confirm it is loads are different? So this load is taking 100 watts, this load is taking 200 watts. Okay, so that voltage will be same because balanced source is connected here. Okay, so here 100 watts, this is 200 watts. So this will take different current and this will take different current, and remaining will be going through this B phase, and remaining also will be going through this another one. Okay, so but as source is balanced, definitely balanced current only should go to the other side. Okay, so that means through the neutral definitely some current must be flowing. Okay, so now some current must be flowing inside this neutral. You can calculate that current also, but no need now. Okay, so here what they are asking, so if okay, so what they have mentioned, another incandescent bulb rating. Okay, so is connected between Y phase and neutral. If neutral wire breaks, then okay, if neutral breaks, that some current will be distributed between other two phases. Okay, so whatever loads are there, through that extra current will be flowing. Okay, so now let's understand one thing. This is 100 watt and rating of this one is 230 volt 100 watts. Okay, so this is also 230 volt 200 watts. Okay, so let's calculate the resistance of this and resistance of this. Okay, so generally what is the formula for resistance? R equals to V square divided by P. Okay, so V square 230 volt for first one. Okay, first bulb 230 volt whole square divided by power is nothing but 100 watts. Okay, so now R2 similarly, R2 equals to V square divided by P. Okay, so that means here 230 volt, same voltage rating, but power rating is nothing but 200 watts. Okay, so now which is higher value, R1 is higher or R2 is higher? See, denominator higher value is there, that means R2 is less. Okay, so R2 is less. Okay, so R2 is less means current, R2 is less means current will try to go through the R2 first. Okay, so that means R2, okay, so R2 value is less here. Okay, so let's understand R1 and R2. Okay, so R1 is nothing but 230 volt divided by 100. R2 is nothing but 230 volt divided by 200. Okay, so here R1 and R2 values we can compare. Okay, so you can understand one more thing. Okay, so here R2 value is less means it can accommodate with normal current. Okay, so and extra current it is taking. Okay, so but you observe this one. Okay, so more heat will be dissipated in the first bulb. Okay, so let's see the options what they have given. 200 watt lamp will fuse out first, 100 watt lamp will fuse first, so both lamps will go. Okay, so actually both lamps will try to glow. Okay, so if the rating is present. Okay, So both lamps will fuse at a time, okay? So it is not possible, because if one lamp fuse out, so if both are having same rating, both will fuse out at same time, and both are fuse out means no problem, okay? So but here if one lamp fuse out means open circuit will be there, okay? So then so it is not possible, okay? So now one more thing, here both lamps are given current now, okay? So that means according to their resistances, it will be fusing out. That means one will be getting a higher voltage or higher current, because of that it will be fusing out, okay? So definitely because of the overcurrent, so the 100-watt lamp will fuse out first, because other one R2 will be accommodating with so because its rating is higher, okay? So then easily it can be, so it will be varying for higher currents, okay? So but R1 will be, so it will take the lesser currents, okay? So that's what we can understand, okay? So otherwise in a different way, okay? So from the current point of view also we can understand, okay? So we can get R2 is less, okay? So R2 is less and R1 is high, okay? So we are comparing these two, okay? So definitely same current must flow whenever neutral is not there, almost same current must flow through all the two bulbs, okay? So now you see R2 is less means I2 is high, okay? Normal, okay? So in normal I2 is high compared to I1, okay? So I1 is less, okay? So just for example, okay? So so I1 equals to 2 amperes, I2 equals to 6 amperes. Just example only, okay? So not valid for this example, okay? So here whenever overcurrent or little bit higher current is coming, I1 current is 2 amperes only. If 3 amperes is coming, which will fuse out first? This I1 current, where it is going in the first bulb, okay? So this will fuse out first. Once it's fused out, so then automatically, so it will be not glowing, okay? So like this, so I1 is less and I2 is higher because of this 100 watts bulb, okay? So will be fusing out, okay? So only for learning you need to understand all these things, okay? So once you understand, so whenever they have connected like that, so previously we might have seen like parallel connection and series connection. Now similarly they have asked like, okay, they have connected in this way, okay? So and one more thing, okay? So here they have not mentioned B phase, okay? So that means so we have a 3-phase 4-wire system like this, 3-phase 4-wire system like this. So between these two, okay, so one load is connected, okay? So between these two another load is connected, only this, okay? So no need to consider this another one, okay? So neutral is not there means only through the bulbs only it is going, okay? So this is even a perfect way of doing, okay? So only for understanding I have drawn all the 3 phases, okay? So because between these two are not interlinked with B phase, okay? This we can understand, okay? So let's see the ECE questions they have given. So find current I1 in the following circuit, okay? So they are asking about I1, okay? So where is I1? I1 is here, okay? So directly they have mentioned 36 amperes of current here. So immediately you have to do this question, okay? 5 in parallel with 20, okay? So how to do? 5 into 20 is 100, 100 divided by 25, 100 divided by 25 is 4, okay? So 4 in series with 6 is 10, okay? So 10 in parallel with 8, okay? So 10 in parallel with 8. You can calculate I2 value, so like 36, I2 value is nothing but 36 total current into opposite resistance, 8 divided by 8 plus 10, okay? So 8 plus 10 means 18, okay? So 18 ones and 18 twos, 16 amperes, okay? So this I2 is nothing but 16 amperes, okay? 16 amperes will be coming like this and it will be divided between these two. I need I1, okay? So I1 equals to 16 into opposite resistance is 20 current division, okay? So 20 divided by 20 plus 5, okay? So 20 plus 5 means 25, okay? So then you can get it as 5 fours, okay? So 5 fours and 5 fives. So then you can get it as 16 into 4 is nothing but so 64 divided by 5, okay? 64 divided by 5 means so it is it 12.8? So 5 ones, okay? So 5 ones 5, so then 5 twos 10, so then 2 will be remaining. So how much will be remaining? 2 will be remaining, okay? So 12 point something, okay? So this is the correct answer for this question, okay? Next question, identify the resistor that draws a current of 5 amperes when connected across the terminals A and B of the circuit shown in the figure, okay? So they are asking about, So 5 amperes, okay. So if you connect some resistance here, it will draw 5 amperes, okay. So no need to read the question 2 times or 3 times, okay. So 5 amperes it will be drawing, and they are asking about this resistance R, okay. So there are so many methods to do this, okay. So we no need to go for a fixed method. So otherwise what we will be doing, so first we will try to find out the equivalent network for this one. This is from the Thevenin's equivalent, okay. So 100 in series with 5, then you will be getting so 20 amperes. 100 divided by 5 means 20, okay. So 20 amperes current source in parallel with the 5 ohms, in parallel with the 20 ohms, in series with the 6 ohms, A and B terminals, okay. So like this. Immediately you have to write down, okay. So 5 in parallel with the 20, okay. So we have already done in last question, okay. So that means so here you will be getting a 4 ohms, okay. So 4 in parallel with the 20 amperes of current source. Current source in parallel with resistance. What you will be getting? 20 into 4, okay. So that is 80 in series with 4, okay. So here it is 4 ohms. Here it is 20 volt, okay. So like this. 4 in series with 6 is nothing but 10, okay. So no need to remove all these things. You can use your rough paper, okay. So this is 10 ohms. So now what they are asking? Current going is 5 amperes here, okay. So 5 amperes. They are asking about this resistance. That's it. 20 divided by 10 plus R equals to 5, okay. So what is the value? 20 divided by 10 plus R means here 10 plus R, what you have to get? 20 divided by 10 plus R equals to 5, okay. So what's the value here? Just simplify, okay. So just 20 equals to 50, multiply this 50 plus 5R, okay. So then you can take it as 5R equals to 20 minus 50, okay. So 20 minus 50 means 30 you will be getting, okay. So minus 30 you will be getting. R equals to 30 by 5 is nothing but minus 6 ohms, okay. So what is this minus resistance? So generally it is not possible, okay. So what we have considered, current is going in this direction, that's what we have considered. But what they have mentioned, maybe, okay, so current is going from this side to this side, okay. So then it will be equal, okay. So then you will be getting 6 ohms, okay. So no need to worry whether it is positive value or negative value, or you can try in a different method, okay. So anyhow answer for this question is 6 ohms, okay. So 6 ohms, and they should have mentioned, okay, so here negative value is not possible, that should have mentioned in the options, okay. So otherwise we can do it in a different way, okay. So here current is 5 amperes we have considered, and this is the R, okay. So again we can do using the nodal analysis here. So this is the voltage V minus 100 divided by 5, V minus 0 divided by 20. So V minus 0 divided by, so how much it is? V minus 0. So divided by this, otherwise 5 you can write down, okay. So let's write down V minus 100 divided by 5 plus V minus 0 divided by 20. This is a leaving current of 5 amperes, okay. So then plus 5 equals to 0, okay. So actually if you consider the current from A to B, okay, so A to B, so then it is 5 amperes, B to A is minus 5 amperes, okay. So anything you can consider. So V minus 100, just take the LCM of this one. So V minus 100 into 20 plus 5V plus 100 into 5, okay. So 500 equals to 0. Just take in the LCM and send the LCM to other side, okay. So this is 20 volt minus 2000, so plus how much it is? 5 volt, okay. So 5 volt, so plus 500, okay. So plus 500 equals to 0, okay. So total it is 25 volt is equals to 2000. So 2000 minus 500, okay. So 2000 minus 500 means 1500, okay. So V equals to 1500 divided by 25, okay. So 1500 divided by 25, okay. So 25 once and 25 6 times, okay. So 25 6 times is 150, okay. So 60 total, it is 60 times, okay. So V equals to 60, we are getting a V equals to 60, okay. So V equals to 60. Now current is 5 amperes from here to here, so that means current 5 is nothing but V divided by 6 plus R, okay. So 6 plus R, so that means 5 equals to V is nothing but 60 divided by 6 plus R, okay. So directly, so from this one you can get R value as, okay. So R value you can calculate, okay. So this is 6 into 5 is nothing but 30 plus 5R equals to 60. So then R value equals to 60 minus 30 is 30. 30 divided by 5 is 6. Okay, so 6 ohms. Like this also we can do. Okay, so just based on the current direction we can understand this. Okay, so anyhow question is very important, and you can check again in a different method also. Okay, so the next question, a circuit reduced to a single equivalent capacitance C and a single equivalent resistance R will have a neutral response given by V of t equals to V naught e power minus t by tau. Okay, so where t is, okay, so t they are asking, so for RC circuit, R into C. Okay, so directly, so in transients we might have seen. Okay, so what is this response? So initially charged, and whenever switch is operated, all the energy is getting dissipated. Okay, so V naught into e power minus t by tau. No need to consider all these things. Okay, so directly they have only mentioned all the conditions. R into C only the option for us. Okay. And the next question, the current through the 2 ohm resistance in the circuit shown in the figure is directly 0 amperes. Okay, so why 1 ohm, 1 ohm, 1 ohm, 1 ohm? Why it is? Because it's a balanced bridge. Okay, so we have solved so many balanced bridge questions. Okay, so whenever 1 into 1 equals to 1 into 1, current going through the middle element equals to 0. Okay, so directly 0 amperes will be the answer for this question. Okay.